Hi everyone, this video is going to help with section 4.3 in the 7th grade textbook, or it could be played in a different class. What this video is going to go over is basically everything we're learning with these negatives and positives that we called integers in the decimal and the fraction form as well. So I have a couple examples I want to give you. So let's go over a couple problems that we typically maybe mess up the signs for that I want to remind you of how to do. So maybe -7 and we subtract 2 more. This is a common one that a lot of people make mistakes on. So if we have -7 and we minus 2 more, if you think of it on a number line, here's 0, 1, 2, 3, 4, 5, 6, 7. Here's -7. If we think about it, we're starting at -7 and we have to minus 2 more. So you're going more in that negative direction. And so your answer is -9. And the other way that we thought of that one is we said, okay, well, if we have -7, we change the sign of the subtraction, change the sign of the next one, so we see they're both the same sign, and add them and keep that sign to get that -9. So there's different ways to think of these subtraction, and this is the commonly messed up one, so I wanted to make sure I brought it up again. And you can use a number line, but when we start getting really big numbers, you won't be able to use the number line. So you have to think about it maybe a little bit different, or rewrite it and think of it as they're both the same sign, so I add them and keep the sign. Alright, so what if we saw a fraction with these negatives in it? So maybe we had 12/13 and we want to add a -1/13. Well, this one has a common denominator, so we're adding, so we can keep that common denominator, right? And so we're going to keep that 13, and we're going to look at just the numerators and the signs across. 12 plus -1. Well, one's negative, one's positive, so that means we have to subtract them. That would give me 11, the numbers, and then keep the sign of the largest one. Well, the largest one is positive, so we're going to get positive 11/13. And we can look at that and see if we can reduce, but we can't, so we're done there. But what happens if those two don't have a common denominator? So what happens if I have maybe -2/3 and I'd like to subtract off 4/7? So I have -2/3 and I want to subtract off 4/7. Well, let's look at these denominators. They are not the same. How do I get them the same? Well, we think about that least common denominator, or we can just think about a common denominator. It doesn't always have to be the least common, but that makes it easier in the long run. So if I think about numbers that both 3 and 7 divide into, so they either have to be equal to one of the numbers or larger. And so the only one I could think of is 3 times 7, which is 21. If you can't think of one, you can just times them every single time. So 3 times 7 is 21. So my new fractions need to be over 21 for both of them. And I'm just going to bring over this minus sign and bring over this minus sign, and I'm going to do everything the same as I would if there were no negative signs in the problem. So I'm going to times this fraction by 7 on the top and 7 on the bottom, so that I get that 21, and I can see that I get -14 over 21. And remember, like, if I think about it, 2/3 and 14/21 are the same fraction, or they reduce to the same fraction. They're equivalent, okay? And I'm getting another equivalent fraction. So I'm going to times this one by 3. So I times the 7 by both of these and the 3 by both of these. 4 times 3 is 12. So we get -14 over 21 minus 12 over 21. Now I keep that common denominator like I did in the last one, and I go look at them, -14 minus 12 more. That we can rewrite that -14 plus a -12. Some way you need to think about, oh, I got to add those and get 26. So I'm going to add those and get 26, and it's going to be negative. Then I look, can I reduce this fraction? 26 over 21. I can't reduce it. It's improper. I usually don't mind an improper fraction. If we would like it to be a mixed fraction, then we say, okay, well, how many times does 21 go into 26? 21 dividing into 26. Again, I'm just ignoring that negative sign for right now. I'm just looking at how to write that number. It will be a negative number, but how do I write it in a different way? Well, 21 goes into 26 one time. So I go 1 times 21 is 21. Bring down or subtract, and so we, not bring down, but subtract, so you get your 5. And we would think of this as 1 and 5 21. So this is the same as negative 1 and 5 over 21. Oops. Okay, so that's, I can go improper, mixed. These are both the same thing. Just look at your directions and look at what way they would like your answer to be. Okay. All right, so let's look at one more here. What if I have negative 12.2, so a decimal, and I'm throwing in that idea of the absolute value as well? And the reason why is because sometimes when we see absolute values, we automatically assume, well, oh, the answer should be positive. That's not true. Well, the answer is positive out of the absolute value, but the final answer may not be. So let's look at this one and break it up. So to get rid of this absolute value, we have to decide, what is this negative 12.1? How far from 0 is it? And that is going to be positive 12.2. Remember, it's always going to be positive coming out of those absolute value signs. Bring down the minus sign. 2.13 out of the absolute value would become, how far away from 0 is it? 2.13. So they both come out, then I subtract them. So we could line these decimals up and we could subtract them, and you put our little placeholder of a 0, and we go, okay, well, 3 doesn't go into 0, so I'm going to borrow 1 here, blah, 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 blah. Bring over the 10, so 7, or 10 minus 3 is 7, and then 1 minus 1 is 0. Bring down the decimal. 12 minus 2 is 10. So I got 10.07. Excuse me, and it's positive because the larger number was positive and this number, or we're subtracting off a smaller number. We could have thought of this again like this too. Woo, I'm allergic. All right, so there's one that has absolute values, and one last problem. I'm folding over the answer because I recorded this video and my audio didn't work. So I don't want to rewrite it. Goodness gracious, I'm really sneezing. Okay, let's say I planted a plant and I pushed it down into the ground 3 3/4 inches below ground. It grew 12.5 inches. How many inches is the plant above the ground? Okay, so let's think about this word problem. I pushed it way down in there, right? 3 3/4, and then the thing grew, 12.5 inches. So, well, how much is outside of the ground? Well, not this part that is below ground, right? So you have this little part that's below ground where you put the little seed, and then he grew up. Well, we know he grew a total distance of 12.5, and we know we planted it 3 3/4. So how can I find just this distance here? Well, I take the whole distance and subtract this one. So I'm going to take 12.5, and I'm going to minus 3 3/4. I liked this example because it made me do a word problem for you that a lot of you struggle with, and it also brought in the mixed fractions that we have to convert and get a common denominator for. So sometimes if they're easier fractions like 1/2 and 3/4, some of you might be able to think of that in your head and be able to subtract them and think through this in your head because the numbers are a little bit pretty. I want you to know a method, well, for when you don't know, like you can't think 3/4 and 1/2 and relate them. So I'm going to make these improper, then subtract them, and then bring them back to a mixed fraction. It is a lot of work, and you really have to do the steps if you want to get the problems right, always. Again, this one's a little easier, so you might be able to think of it. But the way I make these mixed ones improper is 12 times 2 is 24 plus 1. This would be 25 over 2. Bring down my minus. 3 times 4 is 12. 12 plus 3 is 15 over 4. So they're still the same denominators, right? And we just converted it back to that improper. Then I'm going to think of this as a plus and the 15 as a negative. Just rewriting it to think of it the right way. And then I go, well, they don't have a common denominator, but they're close. 2 and 4 both divide into 4. So you don't have to actually change this fraction. You can just change this one by timesing by 2. So it becomes 50 over 4 plus a negative 15 over 4. Now I have them both improper, and I have them both with a common denominator. So what is 50 plus a negative 15? Well, I'm subtracting off that 15 to get 35, and it's positive 35 over 4. This could be your answer, but that doesn't really help in terms of our word problem, right? 35 fourths. Well, like, I can't visualize 35 fourths. So I think, okay, well, how many times does 4 divide into 35? Well, it doesn't go into 3, but it does go into 35, 8 times? 8 times 4 is 32. And then we're going to subtract to get 3. So our answer is 8 3/4 inches. Now you can visualize, right? We can think a ruler is 12. 8, okay, around here in 3/4 inch. Like, you can visualize this. Can't visualize this one. So sometimes we want mixed fractions and sometimes we don't. All right, so I hope this video helped you with working with negatives, also reminding you of how to add and subtract fractions and work a little bit with decimals. All right,